Hello and welcome to section 5.6, which is on inequalities in one triangle. We have the comparison property of equality, which states that if A equals B plus C and C is greater than 0, then A is greater than B. Corollary to the triangle exterior angle theorem. The measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. And that would make sense anyway, based on what we learned in chapter 3 about remote interior angles. Remember that the exterior angle is equal to its two remote interior angles added together. So this is really just another way of stating the same thing. So for my example here, why is the measure of angle 5 greater than the measure of angle C? We could say because it's an exterior angle. Therefore, the corollary to the triangle exterior angle theorem is proven true. Again, we could just use the information that we learned from chapter 3 to figure this out as well. Because its two interior angles have to add up to be equal to the exterior angle, it would have to be greater than its remote interior angles, otherwise that would not work. About this one. So theorem 510, if two sides of a triangle are not congruent, so they're not equal, then the larger angle lies opposite the longer side. So the largest angle is opposite the longest side of a triangle, in other words. Theorem 511, if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So it's basically the opposite of what the other one just said. The one said if the two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. This one says if the two angles are not congruent, then the longer side lies opposite the larger angle. So for my example, if the measure of angle S is 24 degrees and the measure of angle O is 130 degrees, which side of triangle SOX is the shortest side? And you need to explain it. So this is 24, this is 130, so what's left to make 180 here? 130 and 24 is 154, that would leave 26 degrees for angle X. And so since we know the longest side is opposite the longest angle, the shortest side would be opposite the shortest angle then, the smallest angle. So 24 and 26, so angle S is the smallest angle, which would make side OX is the shortest. How do we know that? Because the measure of angle X equals 26, making angle S the smallest. The smallest side is across from the smallest angle. That would be our proof there, or justification for making that assumption there. The triangle, or excuse me, theorem 512, which is the triangle inequality theorem, it states that the sum of the lengths of any two sides of a triangle are greater than the length of the third side. Remember a couple chapters ago we had proven that, because you can't make a triangle unless every two sides add up to be larger than the third side. So the smallest two sides have to add up to be longer than the third side. Otherwise you can't even make a triangle out of it. Okay, it's not possible. So how about this one? Can a triangle have side lengths that are given of 2, 6, and 9 meters? So to do that, I would do, okay, the two smallest sides. So is 2 plus 6 equal to, excuse me, it's got to be greater than 9. Are 2 plus 6, is 2 plus 6 greater than 9? The answer is no. So then I would say it is not greater, so no. The smallest two sides have to be bigger than the third side, otherwise you don't even have to check the other ones. It doesn't matter that 6 plus 9 is greater than 2, or that 2 plus 9 is greater than 6. If we have one set that is not greater, then the answer is no. You can't make a triangle out of that. It won't work without bending the line, and you can't do that. How about this one? A triangle has side lengths of 8 feet and 12 feet. What is the range of possible lengths for the third side? Okay, so I'm going to have to do some work here. So whatever the third side is plus 8 has to be greater than 12. So if I solve this, x is greater than 4. So there's part of my answer. So for the other one then, we'll go x plus 12 is greater than 8. I'm going to minus 12 and minus 12, and x is going to be greater than negative 4. So that one doesn't even really count because we already said that x has to be greater than 4. So the x is greater than negative 4 doesn't really have any impact on the answer. Then for the third side, we'll have to do 8 plus 12 is greater than x. So 20 has to be greater than x. So in other words, if you read that backwards, x has to be less than 20. So x has to be, this is how you're going to write this. You're going to put the x in the middle. X has to be greater than 4 and less than 20. That's my range right here. X is greater than 4 and x is less than 20, and this is how you write it as a compound inequality. That is my range. Greater than 4, less than 20, to be able to make a triangle out of that. So bring that information with you, and we will talk about it more the next time I see you. Have a good night.